In this video we're going to look at some quadratic equations, and the first one is a straightforward quadratic equation and it can be solved by factorising. So this trinomial needs to be factorised, so we'll factorise into two binomials, and we need to think of two numbers that multiply to minus 12 add up to negative 4, so that's negative 6 and plus 2. So that means that x plus 2 could equal 0, or x minus 6 could equal 0, in which case x is negative 2 or x is 6. The next one, the method that's to be employed here is completing the square. So we're going to write that as x squared plus x, leave a space, equals negative 17. And I'm going to come back to that, but I'm going to go to the next line to get our perfect square. Now, the perfect square, there's a relationship between the coefficient here, which is 1, and the number that goes in here. It's exactly half of that. So this is going to be x plus a half, or squared. Alright, because when you think about a perfect square and the middle term being 2ab, then this part here has to be half of that. So we now have to add a number in to make this perfect square actually equal to x plus a half squared. And that number we can get by squaring the 1/2, so that will be plus a quarter. And because we've added a quarter to one side, we need to add a quarter to the other side. So that means that this perfect square here will equal to negative 17 plus a quarter is negative 16 3/4. So the next step is to undo the squaring, or take the square root of both sides, which means that x plus a half is equal to the square root of negative 16 3/4. Now we can't find the square root of a negative number, that's undefined, so that means that there are no roots. In this particular one, we're asked to use the general quadratic formula to find the roots of the equation. So we know that the general quadratic equation is x equals minus b plus or minus the square root of b squared minus 4ac all over 2a, which is equal to, this is our a, this is our b, this is our c. So minus b is minus 7, which is 7, plus or minus the square root of b squared. So negative 7 squared is 49. Take away 4 times a, which is 2, times c, which is 5. All over 2a, which is 2 2's, which is 4. So I might need to go horizontally. So this is 7 plus or minus the square root of. Okay, 5 times 2 is 10, times 4 is 40. 49 take away 40 is 9. And we know that the square root of 9 is 3. So this will be 7 plus 3, which is 10 over 4. And 7 take away 3, which is 4. 4 divided by 4 is 1. And I guess we could tidy that up a little bit by simplifying this fraction down, which becomes 5 on 2. So there are our two solutions to the equation. And in this one, we're not exactly going to find the roots themselves, we're just going to find about the nature of the roots using the discriminant. Now, if we go back a couple of questions, the discriminant in this particular question turned out to be 9, and it led to two different roots. So with this, we're going to find the discriminant, and then we're going to make a comment about the nature of the roots. So the discriminant is b squared minus 4ac. So b squared is 36, take away 4 times 3 times negative 2, which is equal to 36, take away, in fact, because of the double negative it becomes positive, 24, which is equal to 60. So, as the discriminant is greater than 0, we will get 2 real roots.